Earlier this month in Alexandria, Virginia, 150 Pacific Air Force's leadership and allied planners gathered for the G26 benchmark wargame, an exercise conducted at a scale the Air Force has rarely attempted. The exercise modeled 6 days of combat, running 10,000 times faster than reality. The system driving this, WarMatrix, uses physics-based modeling to evaluate dozens of parallel operational scenarios simultaneously, instantly factoring in weather, supply chains, and adversary positioning. This debut aligns with reporting from Bloomberg that Nvidia, Microsoft, and Amazon are all expanding their classified defense contracts. 3 of the world's largest technology firms are now deepening their integration with the Pentagon secure networks in a coordinated move. While consumer attention remains focused on chatbots, the U.S. Air Force is already using generative AI as a co-equal partner in national security, with the outputs from WarMatrix flowing directly into briefings for the Secretary and Chief of Staff. Algorithmic decision speed has emerged as a primary metric for global military supremacy, sitting alongside traditional markers of power like total firepower or fleet size. This shift is driven by the complexity of modern warfare. Engagements now require the simultaneous coordination of air, sea, land, space, and cyberspace operations. In these domains, the volume of intelligence data from satellites and sensors has surpassed what human analysts can process. The sheer burden of surveillance data creates a bottleneck in the decision-making cycle. At the same time, adversary technological gains have compressed the necessary response window. Decisions that once allowed for a 24-hour debate must now be finalized in minutes. Relying solely on human cognitive bandwidth in this environment creates a strategic vulnerability. If one side can cycle through options at machine speed, the side relying on traditional human staff work cannot keep pace. To solve this, the Department of Defense is building a new cognitive architecture within its classified networks. Nvidia is providing the hardware layer. The company has spent 3 years building a dedicated defense business and is now deploying specialized GPUs into classified facilities at a scale it has never reached before. Microsoft Azure Government provides the cloud infrastructure. Their expansion includes hosting defense-tuned versions of OpenAI models and dedicated systems for processing classified datasets. Amazon provides a parallel cloud through AWS GovCloud, which is seeing 40% year-over-year growth as it integrates newer AI accelerators to host models from providers like Anthropic. This structure means the U.S. military has outsourced the physical and logical foundations of its AI capability to a small group of commercial technology giants. In this new model, systems like WarMatrix do not replace commanders. Instead, they act as a force multiplier, providing data-driven insights while a human retains the authority to choose the final path. The outcome is a massive increase in bandwidth. A commander in 2026 can evaluate dozens of operational variants in the same time it took a 2015 staff to evaluate 2. The urgency behind this rollout is the competition with China. The People's Liberation Army has pursued its intelligentized warfare doctrine for a decade, with a stated goal of full AI integration by 2035. Allies are responding through pacts like AUKUS, currently standing up shared AI infrastructure between the US, the UK, and Australia to keep pace. This global arms race ensures that machine-assisted warfare is no longer an option, but a requirement for any major power. Handing cognitive processes over to AI in a military context introduces risks that are built into the technology itself. The first is automation bias. Research shows that as AI systems become more integrated, independent human verification tends to decay. Under the pressure of a crisis, commanders are more likely to defer to an AI recommendation, even when their own judgment is better. This leads to a diplomatic trap. By compressing conflict scenarios into minutes, the window for traditional negotiations and de-escalation vanishes before high-level political intervention can occur. Finally, there is the line involving lethal force. While current programs keep humans in the loop, the sheer speed of machine-led combat creates a constant operational pressure to relinquish control over autonomous targeting. These risks are inherent to the architecture of high-speed conflict, creating a permanent state of precarious escalation where the technology favors action over deliberation. Historically, policy follows technology at a distance. It took 2 decades to develop arms control frameworks for nuclear weapons, and over a decade for cyber warfare norms to emerge. Military AI is moving faster. These systems are being integrated within classified environments today, with almost no public oversight or debate regarding the risks. The basic mechanics of how global powers fight and make strategic decisions have changed permanently. While military AI deployment accelerates, the required policy frameworks remain caught in slow, classified cycles, lagging years behind the operational reality shaping our security.